This is Mr. Fisher. This week we're going to start the WSQ. These are 3 lines in your notebook that I'd like you to add. It's called the Watch Summary Question. And what we're going to do here is we're going to tell Mr. Fisher when, where, and with whom you watched the video. You're going to sum up what you saw. That means what did you learn from the lesson. And another line needs to be a question, right? One question you might have from watching the video. Now I know you might have some questions about the WSQ, so let's answer a few before we get started. What if I don't have a question? That goes with the Q. If you don't have a question, then you write a test question that Mr. Fisher has to figure out, or maybe one of your other peers, one of your classmates. It'd be a very good idea to develop and design your own question. Back to S, summary. How long does my summary have to be? At least a sentence. When you go to write your summary, you need to say, well, I learned about the 8s today. I learned about how to add, how to carry, how to borrow if I'm doing subtraction. Or I learned what a factor is. Doing multiplication, you need to know factors. So at least one sentence. Do I have to do this every time I watch a video? Yes, because the WSQ will help with classroom management. And what will happen if I don't do this? Well, all those that don't have the WSQ done will have to do some other work, while those that have it done will be able to do an activity. Plan on doing the WSQ on every single video that you watch, and make sure it's 1 line for watch, 1 line for summary, and 1 line for question. Welcome. This is Mr. Fisher's Flips third, and today's agenda is right there for you. We're going to introduce a lesson. It's going to be about square numbers and anytime problems. We're going to do some quick practice, problem solve, and a big activity, big assignment right here. We'll be doing something that involves the whole lesson, square numbers. So if you notice, there's odd numbers over here, but look, there's only 2 pumpkins there. 1, 2, that's an even number, right? Nah, I made sure it was odd. There's 3 pumpkins there. Odd numbers versus even numbers. Well, let's get started with the bonus question. I was looking for square numbers everywhere this last weekend, and I came across this, and I figured, you know what? That looks like a nice array. If you notice, there's 1, 2, 3, 4, 5, 6 figures in each of these rows. And if you count that there's 1, 2, 3 rows here, and then that many rows there, you can figure out what the multiplication problem is. Now this isn't a square number. Lesson objective today, square numbers. We need to understand what a square number is and describe square number patterns in the multiplication table. Because we have square mills, a square deal, we need a square number. Yippee! Let's show you what an anytime problem is. Today you need to make an anytime problem. Pause the video, see if you can get this on your own before I show you how it works. We did this by trial and error last time, and so let's do it by trial and error again. Let's start out with 2 quarters and a nickel and a penny. Well, that makes 6 cents. Now we need to get, let's see, 56 cents. We need 10 more cents. We can go 5, 10. But that gives us 1, 2, 3, 4, 5, 6 coins. How many coins do we need? That's right, we only need 5 coins. So 10 or 25, 50, 60, 65, 66. So 66. Well, quick practice. Count with me. Put up your right hand. 7, 14, 21, 28, 35. What did we just count by? Sevens. You just got it. Now, if we take those right hand, we got 7 times 5 equals 35. Now put up your left hand, 3 more fingers. So we have 35 plus 7 is 42, plus 7 is 49, plus 7 is 56. So we know 7 times 8 equals 56. Try doing another couple numbers using your right hand to show that you have 7 times 5 equals 35. And remember, you can also use the calendar to count by sevens. So quick practice, count bys. Count with me. 1 times 7 equals 7. 2 times 7 equals 14. 3 times 7 equals 21. 4 times 7 equals 28. 5 times 7 equals 35. 6 times 7 equals 42. 7 times 7 is 49. 8 times 7 is 56. 9 times 7 is 63. And 10 times 7 is 70. So, practice your sevens. You should also be practicing your eights and your sixes, because these are probably the hardest ones to get, is your sevens, eights, and sixes. By practicing them, you're going to get them down a lot faster than if you just pretend that you practiced. And remember to use your multiplication table. 7 times 7 is 49. We're going to be using that today. Remember it. Well, this part of the lesson, I want to show you what I mean by that. So I'm going to type in 1 times 1, and notice where it crosses. It crosses over, and 1 times 1 equals 1. We can even check. Terrific. Well, let's try 2 times 2. What are we going to get? 4. Excellent. Try a harder number like 4. What's it going to be? 4 times 4 equals 16. See right there? There's the 16. Well, try an even harder one. 7 times 7. I just gave you this answer. What is it? Not 70. 49. Right there. 7 times 7 equals 49. I want you to remember those, because these 7 times 7, those are factors, and it equals the 49. 49 is a square number. Well, let's look at it a little bit closer. All those numbers, 1 times 1 equals 1, 2 times 2 equals 4, they are in this diagonal line right here. See, there's the 49. And which number is missing? Oh, come on. You guys know 10 times 10 equals 100. There you go. So all those numbers, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, those are known as your square numbers. Let's see if you can apply it. Write an equation to show the area of a large square. Well, count with me. 1, 2, 3, 4, 5, 6. This looks like an array arranged into a square. There's 6 columns by 1, 2, 3, 4, 5, 6. Can't we just take 6 times 6 to find the answer? 6 times 6 is 36. Let's check our answer. Oh, you better pause to make sure you did it. Now you can check your answer. There it is. 6 times 6 does equal 36. Well, here's part of your assignment. I want you to pause the video, especially for this part, and see if you can get all the square numbers. There's 6 times 6 all the way to 3 times 3. So pause the video, and I'm not going to show you the answers today, so let's move on. Remember, play a couple games. Here's a reminder of a game that you can try. You get your cards out and you take 10 times, well, let's do our square numbers today. 10 times 10, and so we can go 10 times 10 equals 100. Right? You guys know that. Well, you can change it and do 6 times 6. See if you can get that one. So remember, games are important. Well, let's make sure you understand what square numbers are. How are these two squares alike? You have this one and you have this one. They're square, aren't they? It has 1, 2, 3, 4, 5 squares by 5 squares. That means it's square, it's equal. But this one's bigger. 1, well, better not count that way. 1, 2, 3, 4, 5, 6, 7, 8. Times 1, 2, 3, 4, 5, 6, 7, 8. So they're different sizes based on how many squares are in each square. So they have more squares in this one, right? And less squares in this one. But they are both square. The shape are both square, right? Well, when we look at square numbers, we look at the factors. Like I just showed you, those two squares, one was 5 times 5 and the other was 8 times 8. Well, those numbers are the factors. 3 and 3 are factors. 8 and 8 were factors in that square, and 5 and 5 were factors. But what type of number is 9? 9 is a square number. So back here, what's 5 times 5? 5 times 5, those are factors, equals, come on, come on, there we go, 25. I knew you guys knew it. And if we take this, 8 times 8, oh, there's hard 8s. I can't remember 8 times 8. Haha, there you go, 64. Sometimes you just have to have that multiplication table. Well, how did square numbers become invented? Here's one way that I should ask you. Try to find a pattern in the unit squares. So if we have 1 times 1, we have only 1, right? Well, if we add 3 to that pattern, we get how many? 2 times something, right? Well, what's the pattern here? We add 5 more. Then we add 7 more. Then we add 9 more. We better stop there. Figure this one out. 1, 2, 3, 4, 5 red ones. And 1, 2, 3, 4, 5 red ones. What do we have? What's the pattern? Let's erase that. 5 times what? Do you see there might be a pattern there? The number of squares added with each step follows the pattern. 3, 5, 7, 9, 11. What are we going to add to this next one? 12. You got it. We're going to add 13. So we added 13, but that becomes 6, 7 times 7. See if you can figure that one out. And if we add how many more? 2 more, we get 15. And what's this one going to be? 8 times 8. So, see if you can figure out the next one. How many are we going to add? And what will be the multiplication table? Well, this hundreds table, if you notice, I've got them so I'm trying to hide those square numbers so you can't see them, right? Well, I do want you to see them because part of your assignment, the big assignment, is to make your own. So I'm going to have this on your sheet, and it's going to be her on the website so you can print it off. And you need to either recreate it in your notebook or print it off so you can find out all those square numbers. Now you should be filling in the other blanks. So 1 times 1 equals 1, 2 times 2 equals 4, and see if you can do the rest by yourself. So which number would go there? 2. And what number would go here? 3. And let's put a 4 there. You get the idea? Okay, I'm going to print that off, or you can recreate it in your notebook. And that brings us to the end of the assignment. Have a good night.